Good afternoon, everyone. I'm Shota Olusegun. This afternoon, I want us to dissect or to talk or to discuss this particular topic, and it says explaining the uncertainty principle within TWM limit. So, TWM stands for time energy wave model. So, we're actually going to use two powerful tools to dissect the feasibility of uncertainty principle, though by applying formula of everything, which is the T, the M equals to capital UM plus 4M. By applying this particular formula, which is formula of everything, there is no place, there is no room for uncertainty principle. But we're going to look at the feasibility of it, that why is it that that principle is dominant in is dominant at quantum level, such that if you try to pin the momentum of a particle, you can as well pin the position of such a particle. So we're going to look at how that is so uh, obtainable in the or at quantum level. So now, what I want us to see is that I want us to look at this uh, time energy wave model. Well, this is time wave. It goes up and down like this, and then this is energy wave. It comes down and up like that. From this time energy wave model, you can see that time travels inversely to energy. So the time's wave is inversely related to energy's wave. And what that is actually telling us is that when time scales wide, then energy becomes low. And that is the effect of relativity. So if you're asked what relativity is, you say it is the trajectory of dilated time to, or the inversely, or you can say it's an inverse relationship of time to energy. So it relativity tells you that time is dilated, which is more or less like saying that something is expanded, while the length contraction is actually talking about the shrinking nature of energy itself. So where the length could be the wavelength that is being contacted or being shrinked as length uh, contraction that we have in relativity. So basically, you can say that time energy wave model actually models the relativity effect, which is dilated time to length contraction. Now, if we look at this thing very well, here we have applied formula of everything. We actually put this electron mass value, which is 9.109 times 10 raised power minus 31 kg, in place of this m and this m. And so we have a classical mass worth, which is 2,277,250,000 kilograms. Now, by having this, there is a magnitude or amplitude of wave that comes this uh, with this result that we have, and the amplitude of the wave is 5.7 times 10 raised power minus 48. This being the amplitude wave value at quantum level. Now, if you put this amplitude wave value into the formula again, then you discover that you get a mass worth for electron again, and this time what you get is 0.00000001432. Now we can see that this mass worth is so tiny, so small, so tiny. And if we have this kind of mass worth for electron, which is, contrary to the actual mass worth of electron that we have here, what is that telling us? That is actually telling us that the mass worth of electron in motion is quite different from the actual mass worth when it is at rest. That is, when an electron is really at rest, we get the original mass worth. Now, to get this original mass worth is not to really get this original electron's mass worth. We can't get that within the time energy wave constraint, which is what we have here. We can't. So by applying that formula, the trajectory of that zero annihilation travels beyond the time energy wave limit into higher dimension to really have this original value for electron mass. And what is that telling us? That is actually telling us the real model of the universe, like I said in one of my previous videos. And what that is saying is that the reality of universe is more or less like chains of inverted versions or dimensions. So now, before the full reality of a parallel chain can be ascertained, then it has to go beyond into the other connected chain. And it's until when it gets out of the parallel chain entangled to the other one that you can then really really be ascertained of the parallel chain. So what do I mean by that? If I'm to actually expatiate on that such that we'll be able to understand that, I will have to talk more about how we come about dimensions and what dimensions are for real. Now, dimension starts with a point. Now, I just want us to have a clear picture of knowing both sides, like flipping and get to know what you have at both sides before you can actually say that yes, this is this. Unlike what we have, which is basing the originality, or well, what we have in science now is probabilistic at quantum level. So there is no deterministic result at quantum level. Even though with that, the whole of science experiments and discoveries are actually based on symmetric nature of the universe. Well, the symmetric nature is needed for us to have this equilibrium point. That one is certain. But what this formula of everything is telling us is that the symmetric nature of the universe is not the limit of reality. So reality is far more beyond the symmetric nature of the universe. So now, if we have a point here, this point, we cannot say that, we can't really say what point is this, because this point is not related to any other point that will determine its identity. So we just say we have point. In fact, by having the point right where it is, we don't know the position of the point. And that is why relativity is very essential. You get to know if something is in motion by relativity. You get to know parallel connection. You get to know parallel connections identity by relativity. Then you get to know existential value of something by relativity. So relativity is very essential. So now we say we have a point here. I'm just like trying to cite example, like to think of what I can use to better explain the whole thing. So by having the point, as it is, we don't know anything about the point. We just know there is a point somewhere in space. So we can't really say that, okay, this is where the point is. But now look at what happens when we have another point. Let's say we have another point right here in front of that other point. We have another point here. Now, by having this point, we still don't know this point's identity because it is not being connected to this one. So there is no effect of relativity between the 2 points. And so let's say by the virtue of movement, then there must be a kind of connection. Probably it could be in form of entanglement because they are inversely related to each other. So now once we have this connection between the 2 points, between these 2 points, then we can now say that this particular point is a point in the past, or we can say past point. Why this other point, we can call it future point. Now look at what we are able to get as a result of relativity. Because there is connectivity between the 2 points, then we are able to identify the point, we are able to label the point, and even with this relativity, or this connectivity, we can get to know the position of the point relative to this future point. So we can get to know the position point of this past point relative to the future point. And we can get to know the momentum and the position of this past point relative to this future point. So we define entities by relativity. So relativity is so essential. So now we want to look at uncertainty principle, how that is related to relativity effect. Now, what I want us to know is that here, this value that we have for electron in motion, though here we have, this region is our quantum level region, while this region is our classical level region. Formula of everything is basically developed to unify quantum mechanics to classical mechanics. So now, once we have this value, then don't forget that we have a very straight line here, which is the relativity between the mass, between the classical mass and then quantum mass. So now this line is vertical, straight down. What that is telling us is that this is telling us that the transmission from the classical mechanics to quantum mechanics is instant. That is, the transmission is instant, so it is zero. By having the zero there, it means that they are operating at instant speed, and that is what is called non-locality. But is the transmission really instant? Well, we can say it is instant because of the vertical bar line that we have there. But now, if we look at the mass worth of electron in motion, it is not absolutely zero. We still have some digits, which are 1, 4, 3, 2. We still have that, and that could, exemplify the analogy of atom not being totally or absolutely empty. You understand? But now, I usually say that there is locality even inside the non-locality of quantum entanglement. And that locality that we can say we have is the the factor of suspension that we have here, the factor of suspension, yes, we have the quantum mass value is being suspended. It is not at the extreme bottom of time energy wave model. Likewise, the classical mass worth is not at the extreme top of the time wave relative to energy. And as a result of that suspension, then there is a locality. Even though the information is being transmitted instantly, there is this tiny worth of mass that instantiates that locality, and that is one tangible thing. Now, if we're to look at this time energy wave model, this wave amplitude, which is 5.7 times 10 minus 48, if we look at this wave now, it is a destructive wave pattern, not constructive wave pattern. So if quantum wave and that classical wave, if they collide or they collapse, are we going to have nothing? That is the question to ask. No, we're not going to have nothing, because the mass worth at quantum level is still something like, even not up to 1, not up to, even though it is not up to 1, very tiny, we still have something so tiny to get from the collision of the two waves. Then don't forget that the amplitude of the quantum wave that we have here, we also have the amplitude up here, which is also 5.7 times 10, but instead of minus 48, we have 48. So if they collide, we will still have that tiny mass worth of quantum. Okay, so now, that being said, there is this particular notion about electron being bond with proton. Now, proton is inside the nucleus of every atom. Proton plus neutron. But now, based on the uncertainty principle, it is said that electron cannot actually travel across the ground state into the into that nucleus. If that should happen, then it means that electron can actually travel at a speed faster than the speed of light. And we have seen that kind of situation in a neutron star, where electron is bound with a proton. So why is that possible? How is that possible? You understand? So now, I don't know what transpires here. Maybe the movement beyond this time energy wave model is into nucleus. But let's not say it is into nucleus, because this actually represents the edge of time energy wave model, and probably we may say we have the central nucleus right inside the singularity of the future, which is the black hole. That is what we call black hole. So, but if you look at this, even at the edge, like when you look at the nuclear fusion, when deuterium and tritium, when they are to merge, there is this huge repulsive force that tritium and deuterium must conquer in order to merge and form bigger mass, which is helium. So even at the edge of every atom, there are forces, repulsive forces, keeping the electron to be in orbit. So it is not only the force from the nucleus that is keeping the electron to orbit the nucleus. You understand? So the thing is, after getting the actual value of electron, the value is deposited back into the system, and that resulted into acceleration, and as a result of that acceleration we have continuous increase of energy, and that represents entropy in this system. So with that we get to know that it's actually, moving towards, because the process where we have increased energy, it actually it is talking about what is it called, decay, mass decay. So that process, now we can liken this black hole, the future black hole, to nucleus of atom in that sense, you understand? So now from this analogy we say that the faster than the speed of light is present and it is obtainable. It is not something that we cannot get, but all we need is just to get the actual amount of energy that is needed in order to transit into the faster than the speed of light. So basically what I want us to know is that, imagine we do not apply this formula of everything to get all these values. We get all these values because we apply this formula of everything. And so uncertainty principle has no place here. But imagine we do not have all these values. Then if the electron mass is this tiny, then there is possibility for uncertainty principle to be operational at quantum level, because that tiny mass worth of electron in motion will not be stable. And as a result, if a slight energy is introduced into the system, that will even cause a big problem, because in a situation where you're trying to measure, so if you actually expand the wave more, you are trying to get the position, and if you are able to get the position accurately, then you will not be able to get the momentum. But here we have the momentum, which is 5.7 times 10 raised power minus 48, and as well we have the position, which is 0.000000001432. You understand? So now the uncertainty principle, I think it's part of a relativity effect. But in this case, the relativity effect is from classical mechanics to quantum mechanics. So the entanglement we have is usually at a quantum level. And having this now is another thing entirely. So there could be some delay factor to it. And even if we have this at quantum level, there will still be suspensions. You understand? So the value, that notion of atom not being completely empty is being supported by this time energy wave model. So now the uncertainty era is gone. So we're now in era of deterministic result, and so that is being solved by formula of everything. Yes, glory be to Almighty God. So now I believe this video is quite informative. Okay, but before I call it a day, I want to expatiate more on this dimension. Now, by moving forward, by having this past point and having this future point, we're able to define this past point. You understand? And relative to the past point, we can label this as future point. Now you see that we have a line already, and we can call that 1D, one dimension. Now this point, the future point, is inversely related to the past point, though we may not really see that at work. But now you see that how can we get to 2D? We have 1D right now. How can we get to 2D from here? So for us to actually uh, be ascertained of this line as 1D, we need to move beyond the realm of this 1D. And when we do so, we have 2D, and then we'll be able to get this as 1D. So how do we do that? You will see that for us to get 2D, we may decide to take the past point and the future point and bend them across. When we bend them across, you know that when we bend this line across each other like this, we're going to have a circle. So we're going to have a circle. So now this edge, this blue edge, we have it here, and then we have the green edge, which is the edge of the path here, being joined together. Now, if the sides of each point have been labeled, you will see that even here they are being inversely related. They are being inversely joined. So by having that, then we have moved to the plane section, which is 2D. 2D. Now we have 2D by moving beyond the 1D and then bend inversely to get 2D. Now if we're to get 3D, how are we going to get it? Now don't forget that these line as we have them, they have the feature of a wave pattern because they are being twisted halfway in order to be able to actually join them inversely to each other. But you may not be able to see the clear picture of that here. Now let's say we want to get 3D. To get 3D, 2D is already a plane. So if that 2D should be in form of a line, then it's going to be like this. It's going to be like this. Okay, so now you see that this plane, we have twisted it halfway. It's not that we place it up down, but we place it sideways in order to be able to flip this border point and this border point together. Now if we were to twist this one, the side, and join them together, then it will become a cylindrical shape. When it becomes a cylindrical shape, then it becomes 3D. So I don't know, I think it will be like this. It will then be like this. Okay, so now, so that means we have to go beyond 2D. We have to go outside of 2D realm and then bend the border of the 2D inversely to each other to have 3D, which is the cylindrical shape that we have. So now this is our 3D. This is our 3D. Now this analogy is synonymous to what we have here in this time energy wave model, which means that we need to travel beyond the limit of time energy wave model to get the real identity or the real mass worth of electron. So now the reality of an entity is established at higher dimension. So the reality of that mass worth of electron is not within the time energy wave model, and so you can see how that is linked to uncertainty principle. So that is that. Thank you very much. I believe the video is quite informative and insightful. If so, and you like the video very well, make sure you like the video for real by clicking the like button. Then make sure you share the video with your friends. You can as well comment, let me know your opinion about the video. Then this is a novel discovery. I'm going to put a link to my research publications in the description below, so you can click and use the formula of everything to explore what we have on the board. And then don't forget to share the video with your friends. Thank you very much. God bless you.